global pollution related to the production, transportation, and burning of fossil and nuclear fuels is destroying the world's ecological balance. CO2, SO2, and other pollutants caused by the burning of fossil fuels, such as oil, gas, and coal, are the primary causes of acid rain production and global warming. Estimates show that by the year 2010, the global demand for electric energy will increase by more than 25%. Unless a new non-polluting energy source is developed, this huge global demand will be met by the construction of additional fossil fuel and nuclear power plants, which will further pollute and endanger the planet. Here at the Technion, Israel's Institute of Technology for Teaching, Research and Development, which is the Israeli equivalent to MIT, a select team of scientists headed by Professor Dan Zaslavsky, former chief scientist of the Israeli Ministry of Energy and former water commissioner for the State of Israel, has developed a revolutionary solution that will meet the world demands for future electrical power with a new, non-polluting energy resource. The solution, which can produce power on a massive scale, is called the Energy Towers. The idea for this new power source was first introduced in the early 1970s in a patent by Dr. Philip Carlson, a US physicist. Seeing the tremendous potential of this new idea, the Technion team worked many years developing the technology. The Energy Towers concept that emerged from the Technion research is to build a non-polluting power plant that produces electricity in large quantities and at a low price, utilizing virtually unlimited fuel, hot, dry air, and seawater. The Energy Towers concept is based on a very well-known physical principle in which hot air rises and cold air falls. To demonstrate this principle, we use a small tube and put dry ice at its top. In this model, the dry ice cools the air. The cold air descends and rotates a small propeller at the bottom of this tube. In the Energy Towers, seawater cools the hot, dry air, and the cold air falls and rotates turbines. The Energy Towers will be located in a hot, dry area near a large water source, such as an ocean or a sea. The seawater is delivered by pipes or canal to the operational reservoir, and then pumped to the top of the tower. There, the water is sprayed in small droplets by a spraying system into the hot, dry air, evaporating and cooling the air. As the air cools, it falls and gains high velocity. The wind speed can reach 50 miles or 80 kilometers per hour, rotating turbines located at the bottom of the tower and producing electricity. The brine residue is collected and stored in the brine reservoir, and from there it is conveyed by pipe back to the sea. 45% of the energy produced in this process is deliverable as electrical power. 33% is used for water pumping to the top of the tower, and the remaining 22% are energy losses. Such an energy tower can provide a city of around 1 million residents with all its electricity needs, which is equivalent to 460 megawatts average annual production. To achieve this energy production, the energy tower dimensions must be approximately 1,200 meters in height and 400 meters in diameter. The reason for building the energy tower plant so high is that the production of net deliverable power increases significantly as the tower height increases. The principle behind the energy towers is to exploit a well-known global meteorological phenomenon called the Hadley cell circulation. The Hadley cell circulation is a natural huge heat machine that transfers energy from the equator to the desert areas of the world. The circulation begins when hot, humid air rises from the equator. As it ascends, it becomes cool and dry by shedding rain. This dry air later travels north and south and descends towards two belts. As it descends towards the ground, it is compressed and becomes very hot and dry. This is how the Earth's large deserts and arid regions are created. This air flows back towards the equator, and the process repeats itself. The Energy Towers operation is based on harvesting this hot, dry air as it descends above the desert regions. It flows day and night, and thus allows the Energy Towers to operate continuously, unlike all other solar energy facilities that produce energy only during sunshine hours. In comparison to tall building structures existing today around the world, such as the Sears Tower in Chicago and the Twin Towers in New York, The energy tower's height will be more than twice the height of these structures. The Energy Towers project in its entirety is based on well-known, proven existing technologies. The government of Israel was deeply impressed by the prospect of this project. It formed a committee of experts to examine the project, and their verdict was that this product can be built entirely from well-known, proven existing technologies, and it encouraged the government to support this project to fruition. The committee was convinced of the qualitative correctness of the physics on which the Energy Towers idea is based. An advanced analysis by Professor Yair Tena reflects a reasonable initial cost, though somewhat lower than estimated by Zaslavsky's team. The analysis points out clear economical advantages to the Energy Towers program. The Israeli Electric Corporation, the national electric utility that supplies all Israel's electric needs, saw it as a revolutionary, innovative idea.
פרויקט ארובות השרב הוא פרויקט חדשני, מהפכני.
The Energy Towers project is an innovative, revolutionary, and amazing project in both its scope and the advantages it offers. It is no wonder that such an idea is being developed in Israel, since our country has been the leader in technological and conceptual enterprises in the field of alternative energies in general, and solar energy in particular. Israel Electric Corporation sees the advantages in the project, and for several years now we have been observing the project, supporting it both in terms of finance and research. The Energy Towers project has very clear advantages: no use of fuels and use of clean energies that do not pollute the atmosphere. The output calculations were examined and confirmed by several independent groups of experts, among them the Computational Fluid Dynamics Software Limited Corporation and the Israeli Electric Corporation. The calculations regarding the average net output of 460 megawatts, with its corresponding 400-meter diameter and 1.2-kilometer height, are the results of extensive research, tests, and simulations made by the development team at the Technion.
We calculated the output in many ways, probably 6 different ways. And we were not satisfied until we got the same results in all of them. And it wasn't done only by us, it was done by different people using different methods, and we made a point of it that over a range of parameters, all of us will get the same results. But that's not enough. We ran experiments. We had a wind tunnel models, and we had also a 5-story building chimney where we could run experiments, and we actually ran hundreds of experiments. And we can say in certainty today that we didn't forget to divide by 2 or multiply by 7. Our accuracy today is probably plus minus 10% in estimating the output. And there's absolute certainty about it.
In comparison to other non-polluting energy sources such as solar, geothermal, wind, and hydroelectric power, the Energy Tower is only slightly more expensive than hydroelectric power and far less costly than wind, geothermal, and solar power. One must remember that the Energy Tower's global potential far exceeds the combined output projections for all the other forms of non-polluting energy production. In comparison to other polluting energy sources such as nuclear, coal, oil, and gas, the energy produced by the Energy Towers is not only renewable and clean, but also cheap. As the height of the tower increases, the electricity cost decreases significantly, and this is the reason for a tall structure. The Israeli Electric Corporation examined the possibility of incorporating one energy tower with an average output of 460 megawatts in their long-term planning computer model for future power plant construction. They found that by incorporating one energy tower in an optimal coal-based plan, the expected cost saving would be $1.1 billion. By incorporating one energy tower in an optimal gas-based plan, the expected cost saving would be $800 million. There are over 40 countries in the world with desert regions that can benefit from the Hadley cell circulation. These countries can build energy towers and receive clean, non-polluting, inexpensive power. Most of them will be able to export electricity to neighboring regions. The theoretical potential that exists for the energy towers is to supply approximately 20 times the current world consumption of electricity. In practical terms, in the majority of arid countries, approximately 50% of the electricity can be provided in the near future by the energy towers. The energy towers are a revolutionary idea in that they can produce large amounts of power with no pollution. Potential side effects have all been carefully studied, and technical and engineering solutions have been developed to ensure that the surrounding environment is protected. The main environmental concern was the potential for salt spray drift. Utilizing proprietary technology, almost all the brine residue from the water spray will be collected in the tower and in the diffusers. The balance of the salt spray drift will be contained and collected in an area surrounding the power plant, especially designed and engineered for that purpose. The collected water is stored in the brine reservoir, and from there it is conveyed by pipe to a controlled disposal system back to the sea. That is how the problem is solved and the environment protected.
The absolute thing is that there will be more power stations. And unless we have such a method, there will be more fuel burned. And the question is, do we want another power station that will pollute the air? And the answer is pretty obvious.
There are several major additional benefits to the project. Desalination of large quantities of seawater at approximately 2/3 the price that exists today. One energy tower can provide fresh, clean water to a city of 1 million residents. Inexpensive desalination will also create community, industrial, and desert agriculture development. Additional facilities can be developed for low-cost salt production, and relatively inexpensive inland ponds can be dedicated to farming sea fish and mariculture products. The first countries to build energy towers, which will be the tallest man-made structures on the planet, will benefit from increased tourism and national prestige. And many countries that are not rich in fossil fuels will reap the additional benefits of not having to spend hard currency to import these fuels. The major portion of the research and development phase of the project has been completed. Today, it is at the engineering and construction phase, where a pilot plant is about to be constructed in the Arava Valley, south of the Dead Sea. The pilot plant will be approximately 200 meters in height and 50 meters in diameter. Once the pilot plant is constructed and successfully operated, it will lead to the construction of a commercial power plant. We believe that the Energy Towers project has a great potential that should not be overlooked, and that this project must be realized. As the national power company, we will join the pilot project at the first stage, and later, if it proves itself, I hope we will also take part in the commercial stage, so we can produce energy from this technology.
Energy towers that Professor Zaslavsky and his team are trying to develop is in fact the most promising way to convert on a large scale solar energy into electrical energy. And I believe if this project is going to prove itself economically when it will be realized, we may be making a major contribution not only to the economy of the State of Israel, but to the welfare of the human beings all over.
The energy towers are a first, bold, and serious step of modern society to reverse the ecological damage caused to planet Earth from the exploitation of energy resources. Global energy needs will increase manifold during the 21st century. The energy towers, with its almost unlimited potential to create clean, renewable power, can participate in meeting these needs while protecting our planet.